Okay, so video 4. Unfortunately, we are starting this one out with content that we actually had to skip due to time. I really needed to get to the rate of change because of how important that is, and the graphs of cosecant and secant kind of got pushed aside. So these are the graphs of cosecant and secant. I'm going to try and show you a way to do it if you don't understand it without a calculator, ideally. So here, this says 2 cosecant, right? Cosecant of theta is equal to 1 over sine theta. Now sine at the y-intercepts, there is no horizontal shift. Oh good, no horizontal shift. That makes this a lot easier. At the y-intercept, sine of theta is equal to 0. Right? Remember, if we graph the sine of theta, it equals 0. It goes up and then back down. So this is the sine graph. If you plug 0 into here, 1 over 0, it is undefined. So cosecant of theta is undefined, or cosecant of 0 is undefined, because I'm dividing by 0. So we need to have a vertical asymptote at the undefines. So this one, at the y-intercepts, crosses through it. So this tells me this is definitely not cosecant. This is secant. So we can cross that one out. This one has the same thing right here. We can cross this one out. It should have a vertical asymptote. That leaves this one here and this one here. Those both have asymptotes at 0. So these are both cosecant graphs. Now the other thing we have to check is that we have a period. These are still periodic functions. They have a period. The period is still 2 pi over b. So to find the period is equal to 2 pi divided by b. In this case, that's going to be 2 pi divided by 2 pi over 3. Keep change, flip. And this is 2 pi times 3 over 2 pi. 2 pi's cancel out. The period is equal to 3 units. Okay. So the period is equal to 3 units. Also, check your graph. The asymptotes are going to tell us everything. So we should have another asymptote right here. Every time sine crosses the x-axis, it will have an asymptote. And we'll have another asymptote here. And the distance from there to there should be 3. So we should have from here, skip 1. Because we got to skip, there's an extra asymptote in here. We'll have 2 asymptotes per period. So from here to here is 1 period. Or you can look at it from minimum to minimum. From there to there is 1 period. 8 minus definitely less, so that's 4. So that's 1, 2, 3, 4. So that is 2.5-ish. So this period is roughly 5.5. It's definitely not that. And then we can check the period down here. Minimum to minimum. So the minimum here is 4-ish. Maybe a little short of 4. Hard to see. But here it's roughly 1. So it's got to be D, because the period here looks like it's about 3. So you're probably least prepared for this type of question, but I hope there shouldn't be too many of those. And then if there are, again, just practice the period. They are periodic functions. Practice working on the period and see if you can't figure out from there. And then cosecant, check the asymptotes. When is the function undefined will help us pick the right graph. Which of the following describes the graph of cotangent of x? So, again, the cotangents we didn't work too much on. But tangent Tangent looks like this when it's graphed. Cotangent is inverted. It looks like that. It'll have these asymptotes. Should be shifted over a little bit too. So it should, cotangent is undefined at 0. Cotangent is undefined when cosine is, so cotangent is undefined when cosine of theta equals 0. Because cotangent is sine over. No, I did that backwards. Sorry, cotangent is cosine over sine. So when sine equals 0, cotangent is undefined. There's so much extra room here, I'm just going to write down here. So cotangent is undefined when sine is 0. Sine theta equals 0. Okay, so the graph should have a vertical asymptote at pi over 2. Sine is not 0 at pi over 2. There should be no asymptote at pi over 2. The graph should have a vertical asymptote at pi over 2. Sine is not 0 at pi over 2. It should not have an asymptote there. The graph has vertical asymptotes at pi. Okay, sine is 0 at pi. Great. Where k is any integer and the function is increasing on all intervals. Well, tangent is increasing at all intervals. Cotangent is actually decreasing at all intervals. So it's going to be D. And again, we didn't go over cotangent. Sorry. There shouldn't be too much on the test about it, though, if I was betting. Which of the following graph of f of x equals cotangent in the xy plane? So we want to find out which one of these is cotangent. So we need to have a vertical asymptote at 0. So sine is 0 at this point, so it's undefined. So this is an option. This one is not an option. This one is defined. This one's defined, so it must be B. It must be B. And that's because cotangent is undefined when sine theta equals 0. 22. The function f is defined by, holy crap, all of that. Which of the following describes the domain of f? So this is going to be the set. The domain of this is going to be all real numbers minus the undefined, the asymptotes. Secant theta is undefined when cosine of theta is 0. Okay? The problem with that is that this whole thing right now is your big theta. Oh, sorry, this whole thing is theta. That whole thing is theta. So we know, so cosine, we know when cosine is equal to 0. Cosine is equal to 0 at, so this is going to be at when theta is equal to pi over 2, and theta is equal to 3 pi over 2. So cosine is 0 when the inside, when all of this is equal to pi over 2 or there. So all of this, I need to figure out when all of this is equal to pi over 2. So let's take 1/2 x minus pi over 2. And we want to know when it's equal to pi over 2. When does this equal pi over 2? So if I multiply both sides by 2, I should get x minus pi over 2 equals, 2 times this, the 2's would cancel out, pi. And then I add pi to both sides, or should I add pi over 2 to both sides? And you should get x equals 3 pi over 2. So it should happen at 3 pi over 2. So it should have, this is an excluded value. And now we need one more excluded value, but I'm running out of room. So we also need to know, so we already found one excluded value. Is 3 pi over 2. We need the other one, and that is when everything inside this equation is equal to 3 pi over 2. So 1/2 times x minus pi over 2 is equal to 3 pi over 2. So when this happens, I multiply both sides by 2, and I get x minus pi over 2 over here is equal to 6 pi over 2, which is just 3 pi. Then I need to add pi over 2 to both sides. So we get x, so we want to add pi over 2 over here to cancel that side out. So this is going to be 6 pi over 2 plus pi over 2 is equal to 5 pi over 2. So we should have excluded values, or we should have asymptotes at 3 pi over 2 and 5 pi over 2. These are our excluded asymptotes. So let's see which of our equations omits that from our domain. The domain is a set of all real numbers except pi over 2. Well, pi over 2 is not one of our restricted values. We can actually use pi over 2 in the equation because when I plug it in, all these other things will change where the asymptote is located. So it can't be A. The domain is pi over 2. Nope, can't be B. The domain is all real numbers except when equals pi. Well, pi is not one of our excluded values, so it can't be this one. And then all of them are 2 pi plus 2 pi k. Oh, yes, it's 4 pi, yep. So 3 pi over 2 is one of our excluded values, so it's got to be D just by process of elimination. And give me 1 second, I'm going to find the answer key just to make sure that is correct. It's been a long time since I've done these.